configuration. So if we're done with this, we probably want to get rid of these virtual machines so we don't have to pay for them. Let's go into our stage 1 directory. Type Terraform destroy. We need to use the same password. Fortunately, I picked one that's really hard to guess. And now we need a confirmation. Are you sure you really want to destroy this infrastructure? Yes. So in reverse order, it's going to destroy all of the pieces that it provisioned. And we can watch them disappear on the screen. So that concludes the demonstration. So let's talk about some of the best practices we just looked at. Running Linux on Azure is really simple, but there are some tricks that you can use to get the best performance and best use of your dollars. So we're going to use the ephemeral disk that is created with every Azure virtual machine for our swap. The ephemeral disk isn't guaranteed to save its contents between reboots, so it's a perfect use for our swap partition. Any application storage that we want to have, we're going to use a data disk. We used premium storage data disks that are managed on Azure so that we have great performance. We're going to use application security groups and network security groups together so that we can simplify our network rules. We can apply rules at the application and network level, and they'll apply to all of the resources that are tied to those application and network security groups. We restricted remote access to a specific external IP, which was my IP address. So nobody could get into that machine over SSH except for me. You can also use subnets or multiple IP addresses to restrict those. We used tags when we created our infrastructure so that we can easily search for infrastructure that's assigned to a specific project or a specific time frame. And we used a declarative tool like Azure Resource Manager or Terraform to manage our infrastructure. This allows us to grow the infrastructure over time and make simple changes using DevOps practices. In summary, a well-planned cloud migration will be more successful than an ad hoc migration. Azure Migrate provides a set of tools that allow you to assess the cloud suitability of your workloads, including determining workload dependencies prior to your migration, and then helps you migrate these workloads to Azure. Rationalize your on-premise workloads prior to migrating them. Containerize your applications and migrate the container rather than migrating an entire virtual machine. Determine if any workloads that you plan to migrate still need to be used. You may have workloads that don't need to run anymore. And finally, ensure that your Azure environment is prepared for workloads by using landing zones. This concludes part 1. Let's recap what we've seen so far. In Module 1, we talked about the options for running your Linux and open source workloads on Azure. And we followed up with Module 2, where you ended up with a specific plan for starting your migration. So thanks for your attendance so far. We look forward to seeing you next time for part 2 of this Microsoft Azure Virtual Training Day, Linux OSS database migration, where my colleague Dandy will discuss migrating MySQL and Postgres workloads to Azure.